Good afternoon everyone, myself Nandita. Today I am going to explain about types of an ASIC. In a types of an ASIC, there are three types: full custom, semi-custom and programmable. In semi-custom are divided into two types. One is standard cell based and gate array based. In programmable it is divided into two. One is PLD and FPGAs. And in gate array based, it is divided into three types of gate, that is a channeled gate array and channelless gate array and structured gate array. Now let me tell you about a full custom ASIC. A full custom ASIC IC includes some logic cells that are customized and all the mask layer that are customized. And the microprocessor is an example of a full custom IC, and designer and spent many hours squeezing the most out of the every last square microns of each processor chip spaced by hand. And customizing of all the IC's feature in this way allows the designer to include analog circuit and optimizes memory cell. And for examples like full custom ICs are most expensive to manufacture and it take time to design, and the manufacturing lead time is around the time it takes just to make an IC, not including a design time. It is typically 8 weeks for a full custom IC, that is only to make a IC, not an design time. And these specialized full custom ICs are often intended for specific applications. So we might call some of the full custom ASICs. And in full custom ICs, let me tell you the advantages. One is accuracy, and in disadvantages it takes more time to in the market and even for the design also. And second one is semi-custom ASIC. ASIC for all which logic cells are pre-designed and some post-designed. The mask layer are customized. They are also called as semi-custom ASICs. And using the pre-designed cells from the cell library makes the design much easier. And there are two types of semi-custom ASICs. One is standard cell based and one is gate array based. Okay, in those out of two, let me explain about first standard cell based ASIC. Standard cell based ASIC, that is CBIC, uses a pre-designed logical cells and using an AND gate, OR gate and multiplexer and flip-flop, for example, are known as a standard cells. And one can apply the term CBIC to many ICs that uses a cell, but it is a general accepted that cell based ASIC or an CBIC, that is standard cell based ASIC, means a standard cell based ASIC. Standard cell based area also flexible blocks in CBIC are built of a rows and standard cells like a wall built of a bricks. The standard cell areas may be used in combination with a microcontroller or even a microprocessor known as a mega cells. Mega cells and example mega functions, full custom blocks and system level macrons, that is SLMS, and fixed blocks core and functional standard blocks. As you are seeing, it is a structure of a standard cell based ASIC where the first block is an standard cell area, and the number which are given 2, 3, 4, 5 are the fixed blocks, and each block inches will be a 0.2 inches. The cell based ASIC, that is CBIC, die with a single standard area, a flexible block, and together with a 4 fixed blocks. Standard cell based ASIC, in this ASIC designer defines only a placement of the standard cells and the interconnect in a CBIC. However, a standard cell can be placed anywhere on a silicon. This means that all the mask layer of the CBIC are customized, are unique in a particular custom, as you are seeing on the display. A standard cell based ASIC, each standard cell in a library is constructed using a full custom design method, but you can use this a pre-designed and a pre-characterized circuit without having to do any full custom design yourself. And this design style gives the same performance and the flexible advantages of a full custom ASIC, but reduce the design time and the reduced risk. The advantages of the time or experience or the design by standard cell library and the time needed fabricated all the layers of the ASIC for the design. And the next one is a gate array based ASIC. In this, the gate array sometimes abbreviated, that is a GA. And in gate array based ASIC, that transistor are predefined on the silicon wafer, and the predefined pattern of the transistor on the gate array is based a base array, and the smallest element is replicated to the make a base array in this base cells, sometimes like a primitive cells. And on the top of the few layer of the metal which are defined that interconnect between the transistor and are defined as the designer using a custom and the mask. To distinguish this type of the gate between the other type of the gate array, it is often called as an masked gate array. Gate array based ASIC, there are three types of gate array based ASIC. One is channeled gate array, and second one is channelless gate array and structured gate array. Channeled gate array. A channeled gate array is similar to CBIC. Both use of the rows of the cell separated by a channel used for interconnect. Once the difference is that the space of the interconnect between the rows of the cell are fixed in a height in a channeled gate array, whereas the space between the rows of the cell may be adjusted to the CBIC. The important features of this type of MGA are only the interconnect is customized, and the interconnect uses a predefined space between the rows and the rows of the base cell, and the manufacturing lead time will be between 2 days to 2 weeks. In all the gate arrays, channelless and programmable gate array, it all will be between 2 days to 2 weeks. This is a channeled gate array where the base cell is on the display. Okay, channelless gate array. This channelless gate array architecture is now more widely used. The routing on a channel gate array uses a row of unused transistor. The key difference between a channelless gate array and the channeled gate array is that there are no predefined areas set aside for a routing between a cell on a channelless gate array. Instead, we route over the top of the gate array device. We can do this because we customize the contact layer that defines the connection between the metal one and the first layer of the metal and the transistor. Let me tell you about the features of the channelless gate array. Only the interconnect is customized, and the interconnect uses a predefined space between the rows of the base cell, and the manufacturing lead time, as I told you, it's around 2 days to 2 weeks. And when we use the area of a transistor for routing in a channelless array, we don't make any contact to the devices living under it. We simply leave the transistor for unused. This is a diagram of a channelless gate array, or a C of a gate, that is SOG array dice. Here where the cell based array of the cell based are unblocked. Now structured gate array, third one. The design of the combines of the feature of a CBICs and a MGAs. It is also known as an embedded gate array or a structured gate array. One of the limitation of this MGA is fixed gate array base cell. This marks the implementation of a memory and difficult and inefficient. In an embedded gate array, some of the IC's area is set aside and dedicate it to a specific function. This embedded area either can contact a different base cell that is more suitable for building a memory cell, or it can contain an incomplete circuit block such as a microcontroller. A structured or an embedded gate array die showing on a embedded blocks of the upper left corner, that is the square, that where the square shape is shown is the embedded blocks, and this is our area of a base cell. Tell you about the features of a structured gate array. Only a interconnect is customized, and here the custom blocks can be embedded, and the manufacturing lead time is between 2 days and 2 weeks, and an embedded gate array gives an improved area efficiency on increased performance of a CBIC with a lower cost and faster turnaround MGA. And the disadvantages of the embedded gate array is that embedded function is fixed. The third one is logical, that is PLD. Here an IC that contain a large number of gates and flip-flop that configured the users to perform a different function is called as a programmable logic design, that is PLD. In the internal logic gates or an OR connection of a PLD can be changed or configured by programming a process. One of the simplest program technologies is to use a fuse. In original state of the device, all the fuses are intact. And in original state of the devices, all the fuse are in contact. The program of the program the device involves the blowing the fuse along the path that must be moved in order to obtain a particular configuration of the design logic function. Now, types of PLDs. SPLDs, that is simple programmable logic device. In that, ROM, PLA, PAL and GL, programmable logic array, programmable array logic and generic array logic. And CPLD, complex programmable logic design. And FPGAs, that is field programmable gate array. Programmable gate array. What is FPGA at first? Array of logic gates and a bag of uncommitted computer units or parts, and no defined function, like can be whatever you have designed on the FPGA or create using. As you're seeing, the blocks which are like big, that is a programmable interconnect, and the configured logic blocks as shown, that is a big block. And in this design of FPGA can be created for using in VHDL and hardware disk layer and description language and Verilog. That this FPGA manufactures Intel, Xilinx and Lattice semiconductor microchip technology, etc. The applications are aerospace and defense and medical electronics and image processing and consumer electronics and industrial motor control and scientific instruments and cyber security and wireless, even they are used in wireless communication and artificial intelligence, that is AI. This is FPGA architecture, configurable logic block, CLBs. As you saw first, and it is a digital circuits, sub circuits will be there, and the efficiency of the implement common functions and high flexible, and it includes even the lookup table and the storage element FF, that is flip flops and registers, and a multiplexer. As you are seeing that SRAM bits are 010101, and this is they are used in the 4:1 multiplexer. FPGA architecture, the programmable interconnect, it connects the CBLs to another one, or it connects the CBLs to the external circuits. What is distinguished between an FPGA of other similar device, that is a programmable gate array. That is the main thing is a programmable.